So that finishes the fourth section around the systems view. So we've covered the brief history, what a digital twin is, where is the research, and introduce a systems view. And based on that, and the understanding and the systems perspective, we can think perhaps more about future applications or challenges. I'm going to start with some examples that I've come across from workshops and standards committees, and these are in no particular order of priority. So first of all, first slide, future applications. An area that's getting increasing interest is around remote operation of infrastructure. So that's oil rigs and autonomous oil rigs, and mining, the latter, the big drive in Australia at the moment, to look at how you transition to mines and the role of digital twins in doing that to a fully automated mine. The second area is around development and validation of software for safety critical systems, particularly where you're upgrading the software systems or facilities. So again, think about nuclear power stations. How do you prove and demonstrate that software prior to putting it actually into the system? The third one there is about healthcare and digital twins of the self as an individuals. Do we keep a digital twin of ourselves? And there's some research work looking at that in the UK. Intensive treatment units, intensive care units, and life support machines. And is there a role for digital twins in that context? And the fourth one there is perhaps seems like a bit of a curveball, but it's come up at a number of workshops where people are looking at drones or swarms, and the questions being asked are, do digital twins have a role in order to enhance learning and accelerate the emergence of desirable behaviours? And so what proportion of the swarm might be focused on creating and maintaining a digital twin, and what proportion would just be left to, if you want, you develop and those emergent behaviours. Second slide on future applications touches on four things from a big industrial workshop in the UK. First one was around digital twin systems as context situated robotics, and is this true AI, and actually what's the role of the digital twin? And we're starting to see, there's arguably a convergence between, robots and digital twins, and actually is there an opportunity to bring together the two. The second one is digital twins for personalised upgrades and tuning. So a bit like Rolls-Royce engines, of products that are in service, can you go back and tune or personalise those based on the learning from in service in the digital twin to optimise for the user? Digital twins of supply chains and logistics. We're seeing increased interest there, particularly food delivery systems and perishables, things like meat supply chain. Actually, a digital twin of the supply chain, so you ensure that the security and quality of the food or the items in the supply chain. And the fourth area that's come up quite a bit is around digital twins for transition engineering. The questions being asked there are, what is the role of a digital twin, for example, in helping might be an organisation or a city, for example, actually, can that digital twin be used to generate the learning and understanding to help transition and adjust transition towards, for example, net zero, or to decarbonise a city? And can the digital twin be used to identify the pathways to transition? So how do we engineer transition? And after each stage, you'd almost update the digital twin, run different scenarios again, and use that to guide the next step in your transition. So really some quite interesting opportunities there. Move on now to from future applications to look at some of the wider issues or challenges, and certainly the team here at Bristol are looking at some of these. First one is I've covered at length right at the beginning of this talk, which was really around conceptual stretching and conflation. And I think as a community we need to move past this and rest satisfied with a set of definitions, which I would suggest should be very closely aligned to NASA's definitions, and rest satisfied with those and move on. Again, being very clear about whether it's a virtual prototype, simulation, system model, is it digital twin or digital shadow, or what actually is it? And there's value in digital shadows, creating and maintaining digital shadow just as much as a digital twin, but they are different. Second area is around techniques or approaches for evaluating cost benefit. We're seeing that a lot with our industrial partners who are saying, well, what capability do I need for the digital twin, and what's the cost benefit of this capability? And there's relatively little research on that at the moment. The third one there is around large applications, particularly for cities and the built environment. And we're seeing issues of not only ethics, etc., but ownership and responsibilities. And who owns which models or components or which data, and who's responsible for maintenance or interoperability or compatibility. Some further challenges there. The top one, which I alluded to earlier in the talk, questions being asked around how can models used during product development be constructed in such a way so as to provide the foundations potentially for a digital twin later in life, particularly where model-based systems engineering techniques are being used. Second one there is around ultra-high or ultra-low fidelity models. When and where do you need those, and why? Again, that's about the requirements of the digital twin system. Can DTs really represent human behaviour, or are they complementary to living labs? And this has come up a number of times in the sort of context of the built environment, as to whether you can actually reliably predict human behaviour, or do you need to do a living lab and actually have some combination of the two in the context of future cities, for example. So this is probably close to my penultimate couple of slides now. So what are the challenges for design researchers? Well, I think for us, it's about what are the compelling applications for digital twin? What are the requirements of those applications? Can a digital twin be created using current tools or technologies? If it can, then it may not be a research challenge. If not, why can't it be created, and what are the barriers or restrictions? What are the limiting factors there? And what research is needed to mitigate or remove these barriers or restrictions? The final point in there is one I've really just introduced that hasn't been talked about as much, but I think there's a skills agenda challenge as well. To ask ourselves what are the skills that are needed for future designers and engineers to create, operate, and interrogate digital twins. And based on this talk, I've mentioned design thinking, systems thinking, and model-based systems engineering. And maybe it's a combination of those with other things like IoT, advanced modeling, and those sorts of things. So for us to really think about that, what's DT, digital twins, and the skills agenda. So really the summary threshold concepts from this talk. Firstly, avoid conceptual stretching, conflation, and dissonance. Be clear about whether it's a digital twin or a digital shadow. A shadow is still important and valuable and merits research in its own right. The digital twin is a socio-technical system, encompasses all four elements plus user stakeholders, and there's again significant research in how we actually introduce a digital twin in the context of businesses and a wider organisation. What new business models might that enable, or innovations. The third point there is to think of the digital twin as a living learning loop to generate understanding. If you don't need a living learning loop, you probably don't need a digital twin. The fourth one is about applying some design thinking to the whole, right from requirements to implementation and testing. The fifth one is around future applications, and really what I'm proposing is those will be really future applications are really about those scenarios or cases where learning cannot be generated easily by other means, and where safety, security, and health are really, really important. So critical assets, nuclear, for example. And in some cases, there may be some significant cost savings that can be realised. But I think we've seen from the previous examples that this may not be the primary driver for the creation and maintenance of a digital twin.